Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Nama Budaya, Salam Kebajikan. May peace be upon with us. Distinguished guests, participants of the conference, ladies and gentlemen.
First of all, we'd like to extend our greeting and warm welcome to you all to the 4th International Conference on Engineering, Technology, and Innovative Research 2022, hosted by Engineering Faculty of Jenderal Sudirman University.
My name is Raffi Trianto.
My name is Amanda Mesaluna Putri.
It is an honor to be your Master of Ceremony in this international conference.
The Honorable Dean of Engineering Faculty of Jenderal Sudirman University, Dr. Engineering Agus Marioto, STMT, the Honorable for all participants joining in International Conference on Engineering, Technology, and Innovative Research 2022.
So, distinguished guests, participants of the conference, on behalf of the organizing committee, we would like to say thank you very much to more than 100 participants on this international conference who are joining and gathered together, many of them coming from the part of the regions of this country and also abroad. This is the 4th International Conference, or ICETIR, that held on October 2022, previous year held in September 2021. So, ladies and gentlemen, this conference contains 2 different sessions, which is the plenary session and also the parallel session. First off, we would like to say sincerely gratitude to our plenary session speakers on this meaningful event. Our thanks goes to
Professor Taufik from Coppell State University from USA,
Associate Professor Hairun Nizam bin Ramli from University Tun Hussein on Malaysia,
Professor Muh Aris Marfai from Geospatial Information Agency,
Dr. Adrin Tohari from the National Research and Innovation Agency,
Professor Dr. Insinyur Heru Purnomo from University of Indonesia.
All right, ladies and gentlemen, as the marks of this opening ceremony, we invite you all to sing the national anthem of Republic of Indonesia, Indonesia Raya. And for all the participants, please kindly mute your microphone during this session.
Thank you for all participants. Ladies and gentlemen, we will now proceed to the next agenda, welcoming speech and remarks. The welcoming speech is coming from Dean of Engineering Faculty of Jenderal Sudirman University and to officially open this international conference on Engineering, Technology, and Innovative Research 2022 for Professor Dr. Engineering Agus Marioto, STMT. Time is yours.
On behalf to Professor Dr. Agus Marietto cannot attend for this meeting. This is the representative of him. We proudly to represent Professor Dr. Engineering Agus Suroso. Time is yours.
Okay, thank you. Just a few corrections for moderator. My name is Professor Suroso. Yes. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. The honorable distinguished keynote speakers, invitees, presenters, and all conference participants. Best wishes to all of us. Good morning and welcome to the 4th International Conference on Engineering, Technology, and Innovative Research, ICETIR 2022 from Purbalingga City, Indonesia. The 4th International Conference on Engineering, Technology, and Innovative Research, ICETIR, is organized by Faculty of Engineering, Jenderal Sudirman University, Indonesia. This year, this conference is held virtually on October 12, 2022 from Purbalingga City, Indonesia, co-organized with Faculty of Engineering, Universitas Negeri Yogyakarta, Faculty of Engineering, Universitas Jember, Faculty of Mineral Technology, Akbrin Yogyakarta, Faculty of Electrical and Electronic Engineering, University Tun Hussein on Malaysia, and National Center for Research and Earthquake Engineering, Taiwan. 5 distinguished scholars will start the session as keynote speakers. Professor Taufik from California Polytechnic State University, USA. Good morning, Prof. Taufik. Professor Khairun Nizam bin Ramli from University Tun Hussein on Malaysia. Good morning, Prof. Nizam. Professor Muhammad Aris Marfai from Geospatial Information Agency. Dr. Adrin Tohari from National Research and Innovation Agency. And Professor Dr. Heru Purnomo from Engineering Faculty, Universitas Indonesia. We are very grateful for them to share their knowledge and experience in this conference. It is our great pleasure to welcome all participants of this conference. This conference provides a forum for research professionals and students from various engineering backgrounds in the development of technology and innovative research in engineering field. The 4th ICETIR 2022 invites scholars and encourages the researchers to submit high-quality manuscripts and papers to this conference. I do hope that this conference to be a valuable forum and a good chance to share an exchange of ideas and discussion on all aspects of engineering and technology field for improving the quality and benefits of the research. I would like to thank all staff of Faculty of Engineering, Jenderal Sudirman University, and all university partners and co-organizers. They have been working very hard to organize this conference. I also would like to thank all the steering committees, technical program committees, reviewers, outdoor session organizers, chairs, and other volunteers, and all participants. And to start this conference, Bismillahirrahmanirrahim. In the name of Allah, today, the 4th International Conference on Engineering, Technology, and Innovative Research, ICETIR 2022, is officially open. I wish you all enjoying the conference. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.
for Mr. Suroso what a good welcoming speech for leading us for this conference.
Okay, before that, I also have to say sorry for this piece of this incorrect because the person who just speak are the Professor Dr. Engineering Suroso as the Dean of Faculty of Engineering 2022. Okay. Okay, ladies and gentlemen, we will proceed to the next agenda, which is the plenary session that will be commencing in a few moments. This session will be conducted by our moderator. But before that, we would like to explain and introduce our two moderators.
First, name is Swahesti Puspita Rahayu Eskom MT, academic experience bachelor degree from Computer Science Department, Gajah Mada University, Master of Information Technology in 2007 from Gajah Mada University, work experience 2008 until now, lecturer in Informatic Department in Jenderal Sudirman University, 2019 until now, head of Computer Network in Laboratory in Informatic Department, research areas is computational thinking, IT governance, informatic education.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to the first plenary session of the International Conference of Engineering, Technology, and Innovative Researches 2022. My name is Swahesti Puspita Rahayu. I'm from Informatics Department, Engineering Faculty of Jenderal Sudirman University. Thank you all for joining us, especially our two distinguished speakers that will deliver their speech in this session. They are Professor Taufik. He's the Director of Electrical Power Institute of California Polytechnic State University, San Luis Obispo, United States of America. And Professor Hairun Nizam bin Ramli is Profesor Madya in Jabatan Kejuruteraan Elektronik of Fakulti Kejuruteraan Elektrik and Elektronik, University Tun Hussein on Malaysia. This plenary session will be divided into two parts. The first one is where our keynote speakers will deliver their speeches. Then the discussion will be held after two speakers finish their speech. We have about 30 minutes for each speakers. Now let's start with our first speaker. I will read Professor Taufik's curriculum vitae shortly. Professor Taufik received his degree as a Doctor of Engineering in Electrical Engineering from Cleveland State University in 1999. He's currently a tenured full professor and the Director of Electrical Power Institute of Cal Poly State University, California, USA. He's also the chair of the IEEE Power and Energy Society Chapter Central Coast Section. He held several patents, had received many awards and recognitions. He has industry experience with several well-known companies. And Professor Taufik has also published over 200 publications and served on the editorial review boards of several journals in areas of expertise include power electronics, power system, rural electrification, energy harvesting, renewable energy, and smart grid. Is Professor Taufik ready?
Yeah, inshallah.
Okay, thank you. Welcome, Professor. You have about 30 minutes until 10 past 9.
Okay.
Please welcome
right.
Professor Taufik.
Okay. Auzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I hope you can all hear me. Please let me know if you're having a hard time hearing my speech. First of all, thank you for the introduction, and thank you also for inviting me to this event, giving me the opportunity to share what I've done in terms of research that I've started back in 2011. My passion is in DC electricity. I actually have visited Jenderal Sudirman campus. I've met with the dean, Professor Soroso, earlier a few years ago. And at the time, I actually did a presentation on DC House. And so today's presentation is related to that. The research has evolved into something that can extend upon what the DC House is capable of offering in the more broader applications. And so my presentation today is going to be on, let's see if I can share the screen here. Let's see. Oops, not yet. Okay, can you allow me to share screen? Right now, I cannot share the screen. All right.
Not yet, bro.
Okay, I'll wait. Yeah, while we're waiting on the share screen, I just want to introduce myself. In addition to what has been said, I am currently a faculty member in the electrical engineering department at Cal Poly State University. I've been teaching here since 1999. So this is my 23rd year with Cal Poly. And we are located in California, state of California. I don't know if you've been to the US. California is on the western coast of the United States, and we are right in the center of California, and right next to the beach, and also beautiful mountains. So hopefully someday, inshallah, if you have the time to visit the US, feel free to give me a buzz, and I'll take you to a tour, a short tour in our area. I extend my invitation to do so. Is it? Can I share the screen?
Thank you, Professor. Yes. Would you please try again to share? We already gave permission.
Thank you. All right, now I can do it. All right. Okay. Oh, not that one. Let's see. Can you see the presentation? Oh no.
Yes, bro. Yes.
You seeing the big screen or a small screen?
Speaker view.
There.
Yes.
Is that good now?
Yes, good.
Okay. All right, let's get started. The title of my presentation today, as I said earlier, is related to what I've presented some time ago at University of Jenderal Sudirman when I visited some time ago. Now the title is going to be Hybrid AC-DC House, Paving a Pathway for Future Sustainable Homes. And yeah, the very first slide would be the outline of my presentation. I'm going to start off with future sustainable net zero energy homes, what it means, and then we'll move on to problems with AC, and then the needs to complement with DC, and then I would discuss a little bit about proposed solution, including hybrid AC-DC house, and then following that, we'll be looking at challenges and opportunities, and I'm going to close it with summary. And then in terms of what is the future of residential homes, in my opinion, it would be something close to what we call nowadays, sustainable net zero energy homes, right? NZEH, to be short, will be the future homes where it is defined to be, a grid-tied, energy-efficient house that produces as much renewable energy as they consume over the course of a year, resulting in a net zero energy bill and carbon-free home. Right. And then the house will combine advanced design of different technologies, including electrical technology, as well as sustainable materials, architecture, what have you. And then as of today, this vision would rely mostly on solar panels, as you can see from this picture, right? You can see that mainly we use solar panels because it can easily be molded into the rooftop, right? And then this future home would be, again, in my opinion, incorporating smart sensors, intelligent devices, and making it a smarter house, so we can do some remote control, some smart management of electricity, and so on and so forth, energy storage, and so on and so forth. And most of these devices that we'll be using, all of these sensors, IDs, ICT technologies, mostly this would rely on DC instead of AC. And so this lies the problem, right, or the issues, is that as of today, right, we're still using the AC legacy system, meaning if you look at our house nowadays, we are still running AC system. And if the future house relies mostly on DC, and yet today we are still using mostly AC, then there is a gap there. There is a mismatch there. There's something that we need to catch on, right, in order to be able to be ready when the future, or this net zero energy house comes, is coming by. So we need to be ready. Right? And what we have now is that we still have a gap between what we have now, which is AC, and what the future might hold, which is DC. And so what will be the problems with AC? There's quite a bit. Right? When you have DC loads, for example, then automatically you're going to have mismatching signals, right? AC would have to be interfaced with DC, right? So AC is a sine wave as an example, and DC could be a flat voltage such as this one. And so you have to have something to convert from AC to DC, right? And in the process, unfortunately, in the process of converting from AC to DC, you're going to have some kind of a loss. And this loss is not that, the loss is not small. It's actually pretty significant. It's 17 to 35% loss. So that's a big loss if we are keeping up with AC to DC. And there are other problems with AC. AC is harder to control than DC. The reason being, for example, there is only one type of power in DC. So when we're dealing with DC, there's only one single, power consumption you have to deal with. That would be watts, right? Whereas in AC, we are dealing with more than just one. We have watts, and in addition to that, we also have instantaneous power, we have average power, we have reactive power, we have complex power, as well as apparent power. So there's more that we need to worry about when we are using AC, right? Compared to DC, there's only one that we need to worry about versus 4 or 5, right? In addition to that, in AC, right, usually requires more type of compensation, unlike DC, right? For example, reactive compensation, right? And this could be a problem if you have inductive load, then you're supplying the same wattage at higher current. That higher current translates into higher losses, right? And so on and so forth. So yeah, bottom line is that AC by itself inherently is harder to deal with than DC. Okay, so therefore, hopefully I convinced you enough to be able to conclude that we somehow need to complement, with DC, complement AC with DC, right? And there are reasons for doing this, right? Number one would be increasing number of residential DC loads. A classic example would be LED light bulbs, right? Before it was not being used at all. Nowadays, almost every house will have LED light bulbs. In fact, you'll be remiss if you don't use any LED at all, because LED light bulbs saves energy, right? So, and it would save cost of the electric bill every month. And as you can see, the increasing number of LEDs or LED light bulbs, throughout the recent years. And as you know, LED light bulbs operates with DC, right? Not AC. Same thing with, for example, here I have a picture for smartphones. globally by 2021, which was last year, uh, approximately there were about 2 billions of smartphones globally. And if I take a very conservative numbers, let's say 5 volt to charge as you are charging the smartphone, it requires 5 volts and 1 amp when it's charging, and let's say you're charging for an hour. And globally, when you multiply it by 2 billions, these small numbers translate into a huge number, as you can see here, right? So the amount of energy being processed through DC globally, not just one, but globally, is going to be 10 gigawatt hour. And that's not a tiny number anymore, right? Again, these are all processed through DC. And then we have this upcoming technology, which has become prevalent these days. It's called USB Type-C, right? Now we are all familiar with USB Type-C compared to a couple of years ago. Not many people know about it, but now it's becoming common, right? And what's great about USB Type-C is that the targeted wattage that can be delivered with this connector would be at 100 watts, right? And so that's a great news, because 100 watts could power many things, including your laptop, your TV, if they're running off DC, right? As well as many other chargers for devices. So you can see from just looking at these numbers that the future of DC will be something that we need to watch out for, right? And then another thing would be I've done this. Okay, somebody's turning on their microphone. Okay, so I've done these studies on residential electricities, right? A composition of the loads back in 2000. This is in the U.S. Back in year 2000, the mixture of AC and DC, as you can see from the graph here, right? About 20% maybe DC, and the rest would be AC, right? Mainly is going to be coming from TV, laptop, and desktop. Those are the DC loads. The rest would be AC, such as refrigerator and air conditioning, heater, what have you. And then now in year 2018, which is 18 years later, done some again rough calculation, and it turns out to be that the percentage or mixture of the DC is higher, right? It's increasing from 20% to about 30%. Now, this increase would be due to, for example, smartphones, the increased use of smartphones, tablets, LED TVs, LED lights, and so on and so forth. And I would imagine that the portion of DC loads in developing countries or countries like Indonesia, for example, right, would be higher, right? So imagine, this blue part is actually bigger. This piece of the pie here is bigger in countries like Indonesia. The reason being, in the US, the AC load these are typically big loads, such as big washing machines, big refrigerator, big air conditioning. That's why you can see proportionally the AC load is bigger here in the US than I would say in Indonesia. So I would imagine in Indonesia will be maybe closer to 40%. That's just my guess. And then we have this increasing use of solar panels, right? Rooftop solar panels. And this is actually energy source that will be providing DC. So now you have DC power source right at your fingertip, right? And so that's something that again would hopefully indicate the increasing importance of DC. Now, if you have a DC source on the rooftop, such as PV, you have DC loads, then I would bet that the top method right there, where you have DC source powering DC loads using just DC to DC converter, will be more efficient than using what we are using now, right? We have these days we have solar panels, and then from the solar panel, which is DC, we convert it to AC, and then we convert it again to DC. Then we use DC to DC to finally power our DC loads. So rather than having 3 different stages, we can bypass and just use one single stage conversion such as this, and that would make it more efficient. And if it's more efficient, there will be less loss. If it's less loss, then it will make it easier for us to achieve, this net zero energy house in the future. All right, I talked about smart devices, and all of these devices, as you experience as well, including Indonesia, more and more people are putting cameras, what do you call it, alarm systems, right? Smart garage opener, things like that. And these are all, again, are running in DC. So big market there that would be relying on DC. And not to forget, we also have energy storage, right? More and more people, especially in the US, we've been putting energy storage in their house, right? Such as, improving reliability, basically, right? If the power is out, or if there's more power produced by the solar panel, it can be stored here. The energy can be stored in the batteries. And as you know, energy storage or batteries will be running or operating in DC. All right. So what will be the solution? Well, initially, as I said earlier, I've done some presentation for University of Jenderal Sudirman a long time ago on DC. But now this project evolves into AC/DC. The reason being the DC house by itself is perfect for off the grid, whereas AC/DC will be more suitable for urban areas, right? For cities, for houses in big cities, right? Basically urban house. Now, hybrid AC/DC house operates on crisscrossing AC and DC electrical systems. Has dedicated AC line for AC loads, dedicated DC line for DC loads, and is able to support either load type when their corresponding source is down. And the battery is going to be optional, and also additional source can be connected. So here's the diagram, right, of the hybrid AC/DC conceptual diagram. You have, again, the AC line coming from PLN, bypassing the DC, and it goes straight to the AC loads. And we have the DC line, the DC input, DC source, bypassing everything, goes straight to the DC loads. And then you can see there's a crisscrossing path between the two. The AC can provide power to DC loads, and likewise, the DC can provide power to the AC loads, right? Through all of these technology combined, okay? And notice that I have this MISO converter, which stands for multiple input, single output, which is needed to be able to combine all of the energy coming into the DC bus. And this is This is like a demonstration house. It's not really a house; it's like a shed, right? Where inside we've already constructed the hybrid AC/DC system right here, right? This is just the first demo type version of the demo. We're gonna keep improving it so that it's gonna be more presentable. As of now, it's not really looking that nice, but functionally though, it works very well. We're combining solar panels and the utilities as well as this battery right here. Okay. Challenges on the hybrid AC/DC house. There's always challenges, right? Anytime we are exploring some new direction of some technology, then there's always challenges. But challenges, as you know, present opportunities and beyond, right? Including innovations. So this is actually a golden opportunity for us to be able to be the leader on this technology, right? We want to move fast, so we want to be able to explore more and lead more, right? The challenges that we have, there are many. I won't go through this in detail, but we have limited DC sources, for example, right? So far we're using solar panels, but I'm sure it's not the only way. It's not the only type. And then how can you make those renewable energy sources adoptable, right? That's a question that's really tricky to answer. And then the MISO converter needs further improvement. And then the DC bus and loads are not standardized. And this is more difficult to protect from faults. There's some strict regulations due to ability to backfeed power. and as well as the EMS system that would be great to develop. So I'll go a little bit more details into each. Here's the first one, like adaptability. And here in the US, we have this term or this jargon or term called NIMBY. NIMBY stands for not in my backyard. Imagine if you have a house here, right? Let's say this is our future house. I don't know about you, but I don't want to have a big, huge, humongous, wind turbine behind our house, right? That would be ugly as well as noisy, right? So then that would be a challenge of, hybrid AC/DC house. How can you make these renewable energy sources be more pleasing to see as well as more adaptable to our house? And so I give you two examples. These are already existing technologies. I don't know if they're commercially available, but I don't think they are commercially available yet. But this is just an example where maybe some of you who are interested in doing this would be a direction that you could do to improve the existing technologies. For example, here you have this ridge blade. So basically this is a wind generator right here, right? That's a wind generator that is sitting on top of the roof. So you don't see any rotating part because the rotating part is inside. And you have the rotors hiding or hidden inside this structure right there. So as the wind blows, then the rotor turns inside and that would create the wind energy, right? Same thing with this one right there. This is called a wind power wall. So yeah, you can have a wall to the side of your house, for example, and this wall spins, every single one spins, right? And that would create energy from the wind. So that would make it adaptable, right, to our house. So instead of this, giant wind turbine, now we have a more, more, what do you call it, more or easily installed or easily used renewable energy sources at our house. All right, another challenge is we have so many stuff going on here inside the house. We have the AC load, the AC bus, DC bus, battery, AC load, DC load, all of these devices right here. It'll be nice to have a centralized energy management system that would be able to control and manage all of these sources, if you will, right? So this is something that I have not done yet. And I hope that some of you will be interested in looking into this because I don't have enough background to develop such a, EMS with HMI maybe, human machine interface. That would be awesome. But yeah, that's another challenge. And then here's the MISO. I have the patent back in 2019. There's the multiple input single output technology that I've developed, and that would allow us to be able to converge or combine, I should say, combine multiple sources into one single DC bus, seamlessly with very high efficiency. Right? But still, there's always, things to improve, such as, for example, how can you start developing this into a real product, right? And that will be hopefully someday some of you will be interested. We can collaborate on this, and we can have made in Indonesia, for example, MISO converter. All right. Another challenge would be that DC is not standardized, right? Unlike AC in Indonesia, for example, AC is 220 volt RMS. In the US, it's 120 volt RMS. And so DC, there is no standard. If there's no standard, then if you go back to the load, right, if right here, then what kind of voltage are we using here? What if the load requires different voltages, 12 volts, 24, 48, and how many wall plugs? How many wall plugs are we going to provide, right? So we come up with this idea of having smart wall plug where you can have a smart connection right here. So behind this wall plug, there is a brain that would be able to adjust how much voltage the load will be requiring. So if you plug in a 48 volt load, then the wall plug will be able to get that voltage. Right? And then, as I said earlier, it is a challenge to protect DC because DC doesn't go to zero, right? If you look at DC signal, it doesn't go to zero. Unlike AC, it goes up and then down to zero crossing, and then that's when we want to interrupt the energy. In DC, energy is always high, and so therefore it is harder to break that energy apart if there is a fault happening in the system. As well as arc fault current, this is a topic by itself. Arc fault happens between two wires, that's worn out, and then in AC it's easily detectable in time domain, whereas in DC turn out to be, if you look at the fault current in time domain, they all look the same, so you would not be able to detect the fault. However, if you use frequency domain, we found out that that's the way to do it. So one time ago we did a project on frequency domain solution for DC arc fault current. Opportunities. So once we understand the challenges, what are the opportunities? Opportunities, there's a lot of opportunities, especially for Indonesia, right? This is related to the DC House project as well, right? We have villages that have clustered of houses such as this, right? And if you're so into AC, that's fine. If you still want to run AC, that's fine. But now at least you should be able to have hybrid AC-DC for these houses and then network them, right? Network them together such as this, right? So imagine every house is a hybrid, and then you network every single house or every other house with the centralized, AC or DC bus, to create a network. So that's something that we can also do for this technology. And then improving reliability for rural electrification is another thing, right? On the left, this is the conventional technology for rural electrification, micro hydro, solar farm, wind farm. But what I would like to see in the future is that we have hybrid AC-DC connected into each other or one another, such as this, such that if one goes down and the solar panel goes down, then this house, for example, would still be light, right, coming from the other house, the other sources, right? Instead of this one, for example, if one is down, then the other houses will not be able to support it. So anyhow, increase or improve reliability would be the advantage, right? Okay, other opportunities involve in developing more DC loads, right? That's actually becoming a hot trend in the US, that people are now designing more and more DC loads, such as DC water pump, DC water filtration system, freezer, air conditioning, and so on and so forth. So a lot of DC loads basically that can go into a house. All right, I'm almost done. This is not hybrid AC-DC. These are pictures I'm showing you on DC house prototype. So there's no AC inside. As I said, I've started my research on DC house back in 2010. And since then, I was fortunate to be able to develop several DC houses, DC prototypes, one at Cal Poly, one at Pajajaran University, and one in the Philippines. So if you are interested in doing something like this with me, let me know. I'll be more than happy to help in any way I can. All right. So it's a big undertaking. That's why I'm really appreciative that I've been given the opportunity to share, because this is not a one-person project, right? It takes a village to actually be able to support this project. So the more people get involved in this project, the merrier, right? And the more collaborations between different universities, including myself, that'll be the better, right? So there's still a long way to go. We're not even halfway, right? So yeah, feel free to contact me if you're interested. And as a summary, I hope that from this short presentation, you see the need to explore DC to complement the conventional AC residential electrical system. I believe AC is not going to go away, but what I've been presenting is that it is best for us to be prepared, right? Start developing the technology for DC. That way, when it comes around, we are ready, right? And in order to do that, we at the same time, we are also promoting the use of renewable energy, right? And then maximizing system efficiency when DC loads are continually growing. That will be another goal of complementing with DC. And overall, right, all of these what do you call it? All of these items that I presented, eventually, I'm hoping it would be able to help achieve, the net zero energy houses. Right? That's the future house, in my opinion. DC has technical challenges, but technical challenge present opportunities for new solutions and as well as innovations, and hopefully at the end, business opportunities. Hybrid AC/DC house improves access to electricity in rural areas, and it will be the future house, right? So we need to move fast so that we can be the leader in this new field. And still a lot to explore. And I welcome you to, contact me and maybe do some kind of a brainstorming session or discussion on how we can go, how we can go forward from here, right? And with that, these are the references that I've used for this presentation. And if you have any questions, you can feel free to email me right here. And there's the DCR's website. And that would conclude my presentation. I thank you so much for the time. And billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Thank you
wabarakatuh.
so much for your speech, Professor Taufik. Ladies and gentlemen, please give applause for Professor Taufik. Okay, now we continue to our next speaker, Professor Hairun Nizam bin Ramli. He's a Professor Madya of Jabatan
The
Kejuruteraan.
moderator, you're muted.
Mute. Now we continue to our next speaker, Professor Hairun Nizam bin Ramli. He's a Professor Madya of Jabatan Kejuruteraan Elektronik in Fakulti Kejuruteraan Elektrik and Elektronik, University Tun Hussein on Malaysia. I will read his curriculum vitae shortly. Professor Nizam received his Doctor Falsafah of Kejuruteraan Elektrik degree from University of Bradford in 2011. He's currently a Professor Madya and Timbalan Dekan Pejabatam and also penyelidik utama of wireless and propagation and penyelidik bersekutu in Advanced Telecommunication Research Center in Fakulti Kejuruteraan Elektrik and Elektronik in University Tun Hussein on Malaysia. He's also the senior member of IEEE and Board of Engineers Malaysia. Professor Nizam also had received many research grants and contracts, and he has published numerous publications and served on editorial review board of several journals in his areas expertise in electrical engineering, specialization in radio frequency and microwave. Are you ready, Professor Nizam? For your speech, you have about 30 minutes. Professor Nizam? Are you ready, Professor Nizam?
Yes, I'm ready. Sorry, I cannot hear.
Yes, thank you. Ladies and gentlemen, please welcome Professor Madya Dr. Hairun Nizam bin Ramli.
Thank you, the Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh and very good morning.
Waalaikumsalam warahmatullahi wabarakatuh.
Can you see my slide presentation?
Yes, Professor.
Yeah. Thank you. First of all, I would like to thank the Faculty of Engineering, Universitas Jenderal Sudirman, especially to the Dean of the Engineering Faculty, Professor Dr. Engineering Suroso, and also to the Program Chair, Professor Dr. Wahyu Widianto, for inviting me to the 4th International Conference as a speaker today. So today I will talk about crosstalk mitigation in GFAS. This work is done by one of the students named Ahmadun. He is a staff in Telecom Malaysia, and he's working on the mitigation of crosstalk in the gigabyte fast access subscriber to terminal or GFAS. So first of all, I would like to explain on the content. This is the content of my presentation slide. First of all, I would like to talk about the importance of the work, some background history of the development of digital subscriber line, in the introduction part, and also the network coverage. Next, I will briefly explain on the GFAS transmitter, concentrating on the crosstalk simulator, and I will talk about the crosstalk modeling and measurement technique, together with some important outcome. And next, about the precoder, some results that I would like to share, and some summary and conclusion. I hope you can hear my voice.
Yes, Professor, loud and clear.
Yeah, okay. So in the introduction part regarding the crosstalk, I hope everybody knows about crosstalk. Crosstalk generally is unwanted or transfer of signals between communication channels. This is called crosstalk. And in digital subscriber line, there are two types of crosstalk: near end crosstalk and far end crosstalk. And far end crosstalk can be regarded as the short form of FACS. Far end crosstalk is a dominant impairment in digital subscriber line access network. Weak signal from different twisted pair within the same cable bundle coupled inside the adjacent pair. So in the communication channel, in a telephone line, they have a pair of wires and they are twisted. So when they are twisted, they produce crosstalk, near end crosstalk and far end crosstalk. So especially the far end crosstalk of FACS, cable characteristic is very important for designing the efficient noise cancellation technique. So in order to achieve higher data rates in digital subscriber line networks, understanding the far and crosstalk cable characteristic is important for designing the efficient noise cancellation technique. So this work presents a characterization of cable crosstalk in twisted pair cable in Malaysia and its novel technique of noise cancellation for achieving maximum data rate in GFAS, gigabyte fast access subscriber to terminal systems. So in the introduction part, in the history, the DSL is basically a form of digital data communications technology that enables faster data transmission over copper cables. or copper telephone lines, which utilizes frequencies that are not used by voice telephone call. So during the last 2 decades, as you can see from the figure, there are 2 generations of broadband access networks. Before the ADSL, there is a technique called Integrated Services Digital Network, or ISDN. It is a dial-up modem and can support up to only 128 kilobit per second. So this is meaning that we need to dial up a specific number provided by internet service provider. However, during the first generation of DSL, which is named as ADSL or Asynchronous Digital Subscriber Line, there is no need to dial up to any number, meaning that it is an always on communication. Meaning that ADSL is using frequency bandwidth greater than the voice band modem. By implementing ADSL, no dial-up connection is required by the subscribers. And compared to ISDN, ADSL can support up to around 3 megabit per second of data rate, as you can see from the figure. Later, the VDSL, the very high speed digital subscriber line, support up to 25 megabit per second, which uses the same digital subscriber line to transmit internet signal. It is a new technology compared to ADSL, and it offers better user experience to the internet application users. While VDSL2 is the improvement of VDSL, can support up to 40 megabit per second. And from the figure also, you can see the term bonding, vectoring, phantom. Bonding means uses 2 copper wires from the digital subscriber line access multiplexer to the residents and joins them logically at the data layer as one pipe. So by doing this, almost doubles the bit rate, and it is a standardized technique that applies to both ADSL and VDSL. It also can support up to 60 megabit per second of data rate. While vectoring is the starting point of the gigabyte transmission or GFAS. Vectoring can support up to 100 megabit per second of data rate and is focused on eliminating the impact of far and crosstalk within the binder group. Phantom is a technology that adds a virtual or phantom pair to 2 copper wires. The 2 typical DSL copper pairs operate in a differential mode, while the third signal is injected in common mode via a passing coupling device. Thus, phantom pair adds a third pair data pulse without having a third pair. This is called the phantom technique and support up to 200 megabit per second. While the latest technology, the fourth generation of DSL, is called GFAS, the Gigabyte Fast Access Subscribers to Terminal Transmission. And GFAS can support up to 1 gigabit per second and beyond. So in the figure, you can see the network coverage, especially at high-rise building. At high-rise buildings, which have high population density, the current VDSL2 technology that has been deployed, although it can cover bigger area of population compared to GFAS, as shown in the figure. But GFAS has higher data rate than VDSL2 technology. The DSL-based copper technology needs to sacrifice its distance effectiveness in order to obtain the high-speed data performance. The 250-meter distance here is appropriate to cover the deployment in the high-rise building, because building usually goes up to 100 meter or 150 meter high. So we can cover the network. And this is the reason GFAS is the most suitable replacement technology candidate for high-rise building. So the active element transmission is brought close to the customer, such as the multi-service access node, MSAN, and distribution power unit or DPU. The figure shows the scenario of GFAS deployment at, in Telecom Malaysia before the introduction of the fiber to the home. Despite the vast majority of deployment of fiber, there's still portion of Telecom Malaysia customers that still utilize copper cables, around 35%. And the high-speed broadband internet is Malaysian government commitment towards preparing the country to become high-income country. So in order to support this initiative, Telecom Malaysia is ready to support the network. In the case of copper cable, GFAS is the best candidate to achieve this objective. The figure shows the scenario of the GFAS deployment at high-rise building, where the multi-service is located usually at the basement of the building and uses the existing copper network connected to each in the building within 200 to 300 radius. The GFAS deployment focus for high-rise building with the existing copper network because the fiber deployment is challenging and require high cost of civil work. The figure shows the block diagram of GFAS bitrate transmitter, which consists of crosstalk simulator, discrete multi-tone transmitter, and also channel transfer function as the input to the bitrate estimator here. So the crosstalk simulator is very important in order to estimate the far and crosstalk disturbance in the subscriber line. Crosstalk basically is a leakage into one channel of signal power from another channel. As you can see from here, from the transmitter, signal from transmitter jump into the receiver. This is called crosstalk. And when it is near to the input, it is called near and crosstalk coupling. And if it is far and jump to the end of the receiver, this is called far and crosstalk coupling or fax coupling, as you can see from the slide. And the equation related to this crosstalk is the power spectrum density crosstalk due to disturber as a function of frequency. This one is equal to the power spectral density as a function of frequency and multiply with the transfer function or crosstalk power transfer function squared. So such transfer functions are heavily dependent upon the characteristics and the structure of individual cables and very different from pair to pair and from binder to binder of the copper cables. Next, the figure shows the configuration of the n-length user scenario. This is equal length scenario, the top one, and the bottom one shows the mixed length scenario. Okay, so for equal length scenario, all the customer premises equipment or CPE are co-located, meaning that each CPE will experience similar far and crosstalk noise, and thus it can be foreseen that their bitrate performance will also be similar, regardless the type of recorder used at the transmitter. However, in practice, different pairs of wires within the same cable bundle may terminate the CPE at different segments of cable bundle, resulting in the so-called mixed length scenario, as you can see from here. And because there is the difference of lengths, there is L2 and L1, so there is a equation that we need to include here, L2 minus L1 here. Meaning that the fax into the short loop is equivalent to the length equivalent to the equal length far and crosstalk, and therefore it is what we call a diagonally dominant. Later, I will explain what is a diagonally dominant means. So thus, the far and crosstalk is the only dominant type of crosstalk in GFAS, because usually near end crosstalk should be avoided between the ports at the inputs. So we consider in this work by telecom the far and crosstalks. So the far and crosstalk is the dominant type of crosstalk in GFAS systems. Depending on network configurations, crosstalk coupling may follow different trends. And we can basically model the transfer function of the crosstalk for worst case scenario as shown by this equation. Okay, where F naught is equal to 1 megahertz. F naught is the initial frequency that we define. The initial frequency for the length L naught and the scaling factor KXF is equal to this. And this transfer function can be transformed into equivalent far and crosstalk by these equations. So next is on the far and crosstalk measurement for short twisted pair copper cables. But in this measurement, the cable length used can be, for example, in the work 100 meters, can be 200 meters and 300 meters with 0.5 millimeter gauge of wires. And here we use the two-part measurement technique to measure the insertion loss of the cables and also to produce the far and crosstalk transfer functions. So this is some of the results that we plot in the graph for far and crosstalk. So the figure shows the simulated insertion loss. As you can see from the black line here, this is the insertion loss of the twisted pair cables, 100 meter long, and single slope stochastic far and crosstalk model, and also the enhanced far and crosstalk plots for blue color and red color. So the dispersion of crosstalk increased about 10 dB from, because we are using different standard deviation. Standard deviation, sigma here. The top plot is using 5 dB and the bottom plot using 8 dB of standard deviation. This eventually affects the level of crosstalk where each pair in the copper bundle experience different effect of the crosstalk dispersion. The root cause of this behavior is because the construction of the copper pair in the bundle may exhibit different crosstalk level. So it is observed that this stochastic single loop enhanced FACS model is not capable of simulating a non-row-wise diagonal dominance channels, since the far and crosstalk transfer function is always weaker than the insertion loss for 100 meter. As you can see here, for frequencies up to 50 megahertz, the insertion loss is greater than the crosstalk. However, once the equally length far and crosstalk overlaps the insertion loss, the channel frequency within that range cannot be used. This is what we call the row-wise diagonal dominance, or RWDD matrix, where HK here is the transfer function of the crosstalk, where HK here is the n times n matrix, such that the inside matrix consists of component of each crosstalk of the adjacent pair of the wires. So for example here, the insulation between the twisted pair increases the attenuation As a result, the crosstalk channel is called the row-wise diagonal dominance, or RWDD. Otherwise, it is non-RWDD when the upper element of the matrix is higher than the diagonal elements. So the figure shows the measurement samples of the insertion loss and other examples, and also shows the far and crosstalk transfer functions obtained on a 50 pair. This is the case for 200-meter cables. In this figure, the cable starts exhibiting the second slope of the far and crosstalk around 80 megahertz when the distance becomes longer, implying that the far and crosstalk coupling coefficients could be stronger than the insertion loss, hence turning the crosstalk channel matrix into non-RWD effect, as you can see from the figure. And these are another example of non-row-wise diagonal dominance plots, as you can see. And this is for 100-meter cable. As you can see, the top element of the matrix has a higher magnitude compared to the other element from the matrix. So in telecom, we use pre-coding as a technique to mitigate or to suppress the crosstalk interference at the transmitter and also at the receiver. Since signals are transmitted from the same location, pre-coding can be applied to pre-distort so that the crosstalk signals arriving at the customer premises equipment are mitigated. In GFAS system, pre-coding is compulsory requirement based on the standard ITUT G9700, which is based on the power spectral density, and G79701 on physical layer. So pre-coding has two types, linear pre-coding and non-linear pre-coding. And examples of linear pre-codings are zero forcing precoder, diagonalizing precoder, and equal power precoder. There are others like maximum ratio combining or transmission, beamforming precoder, and also transmit winner precoder. And non-linear precoder examples are Tomlinson-Harashima precoder. Another example like Costa precoder and vector perturbation precoder. And linear precoder is used for row-wise diagonal dominant case, while non-linear precoder is used for non-row-wise diagonal dominant case or non-RWDD case. So in this plot, you can see that we use the use of precoder for noise cancellation will basically eliminate the effect of crosstalk. The bit rate will close to zero fax condition, meaning that the effect of far and crosstalk for not using the precoder will degrade the bitrate performance of the disturbed line. The figure shows the achievable bitrate performance of customer premises modem using different linear precoders. This is the case for 5-user equal length scenario. Okay, well, as you can see, this is the plot for far and crosstalk without precoder, and the top one here with precoder. They are overlapping between zero forcing precoder, diagonalizing precoder, and equal power precoder, which equally or reach or the same as a zero far and crosstalk plots. Next is for a non-linear precoder for non-row-wise diagonal dominant case. The figure shows the average achievable bit rates exhibited by non-vectored, and Tomlinson-Harashima vectored GFAS systems. Vector mean precoding or precoder. Yeah. as a function of a loop length for single, also for, but this one we use for one user, single user, 5 users, and also for 10 users, without pre-coding and with pre-coding. So you can see the plot here. By using a precoder, we improve the data rate in the downstream achievable bit rate in megabit per second. This is what we call the hybrid precoder that combine the linear precoder and also non-linear precoder. But also we have the opportunity to select for some, and there are some parameter used in this flow chart, as you can see. That first we set the tone to K1 and the switching mode. There are 4 parameters here. I'm not going to be too technical, but this is, we have delta, epsilon, alpha, and beta. Any parameter we compute mu k here. Mu k by introducing the switching threshold. Mu k is the switching threshold here. And but first we need also to compute dk. Dk is the maximum of the crosstalk. Okay, maximum amount of crosstalk obtained. So if the mu k is, if the threshold is less than delta, then it will select either silent mode or non-precoded mode. Similarly, if it is greater than delta, it will select a non-precoded mode or precoding. And if dk is less than a certain threshold, for example, beta, it will select linearly precoded mode, linearly precoded mode. And after that, it will adopt the current selected mode to tone k, and it will feedback. It will feedback the loop to determine which control signal to be transmitted to the CPEs until k plus 1 is greater than k. Then it will transmit control signal to the customer premises equipment, and then the signal, the precode data signal, and transmit precoded data to the customer premises equipment. So these are the hybrid precoder that used in telecom. This is one example of hybrid precoder that they use, and it is also called the quad mode precoder or QMP because it consists of silent mode. It consists of 4 types of coding mode: silent mode, non-precoded mode, linearly precoded mode, and non-linearly precoded mode. So there is 4. We call it a quad mode precoder or QMP. And because it involves the matrix, we call channel matrix quad mode precoder. This is the simulation case scenario for hybrid precoder simulation case for 16 users. In order to study the effective mitigation technique for precoder performance under more diverse loop lengths, we consider a 16 mixed length scenario, as you can see from the figure. So the multiple length scenario is introduced in order to identify the impact of the hybrid precoder. In this loop configuration, you can see that the shortest distance here to the customer premises equipment is 25 meters here. 10 meter plus 50 meter, for example. So the shortest customer premises equipment to the distribution point is 25 meters. And the longest distance, if you carefully calculate, it is 250 meters to the customer number 16. So the loop lengths of all CPAs are shown in the figure. Each customer will have different value of insertion loss and far and crosstalks. So this is the result of using the hybrid recorder performance. It is almost equivalent to the, if you see the plot of the green here, the hybrid recorder that we use is almost similar to the diagonalizing recorder and also to the Tomlinson Harashima recorder. They are almost the same. For low frequency, the linear recorder is selected and it changed to nonlinear recorder once the frequency is beyond 50 megahertz and above, as you can see from the plot. So in summary, the far and crosstalk noise can lead to significant degradation in achievable G-fast bit rates. So to ensure successful deployment in G-fast technology, it is essential for far and crosstalk to be reduced or removed by using pre-coding. And there are several types of pre-coding that can be employed in the G-fast transmitter. And lastly, the work paves the way for the development of crosstalk modeling and mitigation technique for crosstalk cancellation in the future G-fast systems. So that's all my presentation. Thank you very much. If you have any question, you may ask. So thank you.
Thank you so much, Prof. Nizam. Let's give applause, ladies and gentlemen, for Professor Nizam. Now we open the discussion session. You can ask your question through chat message or raise your hand. Please state your question and mention to whose speaker you're asking. The committee, can you please show the chat on the screen? While we're waiting, I repeat once again, please, you can submit your question through chat message or raise your hand. And then please can you state your question and mention to whose speaker you're asking. This is from Pak Wahyu Widianto. A question for Prof. Taufik. Very interesting presentation, close to our daily life. Is collaboration with civil engineering open, Professor? As we know, civil engineers usually design houses and buildings and study building materials, while Prof. Taufik's presentation mentioned the increase in the use of DC electricity in houses and also development of net zero energy houses. Professor Taufik, can you please respond to this question?
Yes, very good question. Yeah, when it comes to a building or a house, I think easily we can say that this is a combination of different disciplines that could contribute to the development of or enhancement of in a future house. Yeah, although the presentation that I gave earlier related more to electrical side of the building. However, there are other things that other majors can also contribute. Um, Civil will be a good one. I'm not, an expert on civil engineering by any means, but with the little knowledge I have on the civil part, one example would be, what would be a good way. And I showed you the picture of this ridge wind turbine, that you put on the rooftop, for example, right? I'm pretty sure there's something that you can do there in terms of, what will be the optimum angle to place this structure, right? What will be the position of the roof by itself with respect to the elevation of the house or things like that, right? How much you can gain by increasing the structure above the house, things like that. And another thing would be, you probably heard about solar panels, roof tiles, right? Where you put roof tiles on the roof, of course, but then the roof tiles themselves are, solar panels. And so, what will be the most optimum shape, optimum angle, things like that. Material-wise, I've heard quite a few times that material-wise you could also help in the achievement of this net zero energy house, right? Because keep in mind that net zero energy house, the net zero energy, that can come from different ways. It's not just from electricity, but also in the way we consume energy in the house, right? That could be from insulation. It could be from the materials that they use for the house. So what would be the good material to use for the house? I've heard about using bamboo, for example, or any type of what do you call it, like a mix of materials. Again, I don't know much about, but I've heard people are looking into putting different materials for the house to make it more energy efficient, right? Not from electrical point of view, but from like, for example, heating, distribution, cooling purpose, and things like that. So definitely this is something that I would encourage you to look into, because as I said in the presentation, it takes a village to develop this type of technology. It's not just electrical, civil, mechanical, computer, architecture, right? You name it. And also on the business side, on the social science side, and that's something that I'm pretty sure that's always a field that could get some help on, from these other fields of science and engineering. So yeah, the short answer to your question is yes, definitely there's something that we can collaborate with if you're interested in doing so. So thank you for asking the question.
Thank you, Professor Taufik. Next question, please. From Pak Yogi Ramadhani, Prof. Taufik, why is 48 VDC recommended for DC house? Because we are still using the 12 VDC system for the greenhouse here.
Yes, that's another good question. The main answer to that question is that, at least in the US, I don't know how it is in Indonesia or other countries. In the US, 52 volt is like the threshold, the limit voltage for DC, above which you're going to have to follow codes. So if you want to develop a system that has a DC voltage higher than 52 volts, you could, but the price you have to pay is that you have to follow, codes, right? So you have to follow regulations. You have to strictly, be in terms or align with, the rules and regulations that we have here in the U.S. And anything below 52 is free. It's free to use. You don't have to worry about all of these strict policies and regulations. That's the reason why I picked 48. And 12 volt, you could use it, but as the power goes up, current goes up as well, right? And lower voltage means higher current per given wattage. So therefore, you're going to end up with bigger loss, right? If you have a lower voltage. So I'm sure there's a trade-off, and 10 years ago or so, we did a study on what would be the optimum voltage. Two independent studies, two different groups of students, and interestingly enough, both groups came back to me, and they didn't know each other. They came back to me and reported that 48 is actually the most optimum. That's the reason why we ended up choosing 48. However, 48, it's still too close to 52. So when we talk about 48 volt DC, it's not going to be a flat volt. It's not going to be a flat voltage. There's going to be some ripples, and that ripples could go up to 52 volts or even more. If that is the case, then we are violating the codes. So that's the downside of 48. Okay, it's that it's getting too close to 52. So ideally, I would say maybe 42. But 42 is such an awkward number for DC. But 48 is what I found so far will be the most usable, right? So that's the answer to your question. Hopefully that answers it. Thank you.
Thank you, Professor Taufik and Pak Yogi Ramadhani. Ladies and gentlemen, because the time is up, I'm sorry we have to close this plenary session. We'd like to thank you and send our gratitude for the keynote speakers and the participant who's joining us today. It's been a very interesting speech. We hope this session could rise up our knowledge and expertise. So good evening for our speaker in USA, Prof. Taufik, and good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you.
Okay, thank you for the moderator and honorable speakers.
All right, now we'll move on to the next plenary session, the second plenary session. But before that, I will introduce our moderator. He is Mr. Yanuar Haryanto, PhD, who was born in Banjarnegara on 17 January 1981. And also his educational background, he is a PhD in Structural Engineering, Department of Civil Engineering, College of Engineering, National Cheng Kung University, Taiwan. And also about his achievements, published more than 35 Scopus Index papers in several reputable journals and conferences. Winner of the Outstanding Award in the 2022 National Cheng Kung University Grand Review and Competition. Winner of the 2021 National Cheng Kung University Sinopec Outstanding Academic Performance, and also the winner of the Best Paper in the third ICETIR 2021.
So, good morning, everybody. Good morning, ladies and gentlemen. Now we arrive in the second plenary session. We will have three remarkable speakers in these plenary sessions. One is Professor Muhammad Aris Marfai from Geospatial Information Agency. And the second is Dr. Adrin Tohari from National Research and Innovation Agency. And the third is Professor Dr. Insinyur Heri Purnomo from Universitas Indonesia. So I would like to introduce myself first. My name is Yanwar Haryanto. It is my honor to be a moderator in this plenary session. So for the first speaker, I would like to read his curriculum vitae shortly. So Professor Muhammad Aris Marfai, born in Klaten on January 13, 1976, and he received his doctoral program on 2008 in Germany with the predicate of magna cum laude. He has very rich experiences in his field, and we believe we would like to gain some knowledge from his speech. So for the first speaker in this second plenary session, Professor Muhammad Aris Marfai, time is yours.
Thank you very much, moderator Pak Yanwar and everybody. The committee, please allow me to share the screen. May I get the access to share the screen?
Yes, Professor, just please wait.
Okay. Thank you. Okay, I hope my voice is clear and sound enough.
Yes.
And also the PowerPoint are clear enough.
Yes.
Good morning, ladies and gentlemen, and good morning everybody here. First of all, I would like to introduce myself. My name is Aris Marfai. Currently, I'm the chief of the Geospatial Information Agency of Indonesia. This agency has the responsibility to develop and also to to integrate geospatial information data in the national level and also as well as in the regional and also in the local level. This agency is directly responsible to the president as what we call lembaga pemerintah non-kementerian. So our task is to do and to develop the geospatial information. Part of this geospatial information would be related to the technology, what we call as geospatial technology. And this geospatial technology currently if we have looked in the recent development on the world, this is play a very important role, and therefore it can be considered as the sustainable engineering and technology for better life in our community right now. Ladies and gentlemen, I would like to start with the condition of our world currently. In our daily life, we could not, we depend on the spatial, some information and data. This also include the spatial information. In daily life, we use a map, for example, Google Map. We use more application which is based on the geospatial information. Like, for example, you use Gojek, Grab, you use Waze and other direction, you use GPS, etc., and so on. And those information, those applications are based on geospatial data. So therefore, the application of the map itself are very broad function, we can do for searching engineer, we can do for routing our path, we can calculate our destination, direction, etc., and so on. So therefore, for this, we need what we call Peta Rupa Bumi Indonesia, or the base map. So actually, our base map consists of the several information, and at least there are 7 layers should be there, including the hydrography, contour or hypsography, building, network, transportation and utility, and borderline, as well as the toponymy. So those information are basically the most important information when we are dealing with the mapping. So before I start with this map, have a look the global statistic of the our use of the information through our application or through our mobile application, for example. In this application, in Android and iOS, etc., and so on, almost we use what we call as Google Maps as our navigation and as platform for some application. And if we have a look this, meaning that geospatial technology play a very important role in our community right now. So based on this, just to inform you that currently I'm in India, Hyderabad, just today, to follow the second United Nations World Geospatial Information Congress. So I'm very happy also to share with you directly, still fresh from the oven, from this hall of the Congress. Yesterday we are talking and discussing about the direct impact of the geospatial technology on the world economy, for example, 2020 to 2025 and 2030. I just catch up this slide just this morning before I start, because I got this yesterday on the plenary session that we discussed about the impact of the economic due to using the geospatial technology. In some part, there is the distribution of the technology and market drivers of the geospatial information. For example, currently we are dealing with the integration of geospatial and technology for creating digital twin and metaverse, and also increasing the digitalization and workflow of the integration. For example, the network flow, the analysis of the network, etc., and so on. Also, we are dealing with the geospatial industry transition to offer enterprise solution and services. Right now, currently, we can see that some of the industries already serve the detailed mapping, for example, using the LiDAR, and this is very useful for infrastructure building and engineer to provide the more detailed data, for example, on the field of the civil engineering, etc., and so on. And also this technology on the geospatial create the evolution of the business model for the web services, for example, currently are available, and startup based on this application, startup based on this data, geospatial data are merged right now. And also we are dealing with the high resolution, volume, and velocity of the spatial data. We are dealing with the big data, artificial intelligence data, Internet of Things related to the geospatial data, etc., and so on. And in the future, now we are facing what we call geospatial ecosystem, future geospatial technology ecosystem, meaning that the geospatial technology can contribute more and wider in the several aspects of the society, especially to sustaining the digital economy of the society. For example, on the agriculture sectors, using geospatial technology improve the agriculture or farming, precision farming, for example, and also improve of the management of the agriculture itself by providing the spatial data and information. And also in the construction and infrastructure, this is no doubt, we need more detailed data. For example, if we are doing the building the road, you need the more information related to the special aspect. For example, related to the slope angle, related to the distance, related to the geological condition, distribution of the material, etc., and so on. And also in the logistic and supply chains, we need the chain distribution, the geographic distribution, the network analysis, which is all those things. Yeah, we need the geospatial information. Also in the cities, no doubt, we have the tata ruang, we have the spatial planning, detailed spatial planning, and all those things need the basic map to do the analysis as well as to develop this city itself. And also in the public safety and security, currently we are dealing with the more issues related to the regional security, for example, and also related to the, for example, the public safety and the distribution of the facilities, health facilities, etc., and so on. Autonomous driving, for sure, we need detailed map. More than 500 scales, 1,000 is not enough because we need the more detail, the location, the coordinate, etc., and so on. Also in the land administration, currently we are dealing with, for example, our policy to give or to provide the certificate, land certificate to all the Indonesian land. So meaning that the technology on mapping are very important and necessary. And this is also from yesterday meeting in the Congress, how the extended of the impact of the developing or using the geospatial technology, meaning on the new collaboration, for example, the increasing domain accelerator and incubation network, also the new collaboration agreement within the geospatial industry and also with outside of the geospatial industry, etc., and so on. And this is the figures showing us the sectoral geospatial market in the current future. And the climate service, for sure, we are using already since a few decades, and also the maritime and inland waterways and road and automatic urban development also. And nowadays the infrastructure, location-based services, etc., and so on. So this will be very important. According to the Geospatial Knowledge Infrastructure Readiness Index, this book just launched yesterday. We can see the value proportion in the world economics of the using the geospatial knowledge infrastructure. And us in Indonesia, we currently on the ranking of 33rd around the world related to the development of the geospatial knowledge infrastructure. We already on a good position and a performance on the integrated policy framework, meaning the policy in the national level, regional level, as well as between the geospatial and non-geospatial policies are engaged. So in terms of the foundation of the data, we need to do more on the positioning infrastructure, as this is still weak in our position. And also in the partnership and collaboration, we are very good achievement on the international partnership as well as the geospatial collaboration. As well as in the industry leadership, we should also pushing and encourage our industry capacity related to the geospatial technology. We know that this is still homework to do, to how we encourage the industry to develop the more, to provide and to facilitate more industry to push the capacity in order to help on the development of the geospatial technology in a national level. And also in the application analytic and modeling, we are good in the good performance as well as the geospatial dimension to digital infrastructure. Also, we are in a good performance actually. Therefore, we are number 33rd around the world. This is not bad position, though we still need to encourage ourselves. In order to encourage ourselves to increase our readiness in the geospatial knowledge infrastructures, we do our task in the PIG, for example, nowadays we are developing the plan to do the large scale mapping, 1.5 thousand. And this is very important in order to support the investment, in order to support the spatial planning, detailed spatial planning, in order to support the economic growth, etc., and so on. So we are dealing with this large-scale image, large-scale mapping in cooperation with BUMN using the what we call KPBUMN, kerjasama pemerintah badan usaha milik negara, under the Kepres 11/2021. So this is some of the regulation. I can just skip this one. Several methods that we use for our technology to acquisition of the geospatial information data. We can divide it into 3 categories. In the first, in the urban area, we need more detailed data in the very high level of the quality using the airborne as well as the LiDAR, and also using the aerial photographic, both metric or non-metric. And then later on in the rural area, might be less detail compared to the urban area. We use the combination of the Citra satellite resolusi tinggi, or we call the satellite images, the large scale of the satellite images in combination with the airborne SAR. And also later on in the forest, for example, in the forest area, we can do the combination of the aerial photo and LiDAR, etc., and so on. So this is part of the technology behind the acquisition data, some part of the how we do the LiDAR and the photogrammetric, and as well as how we do with the remote sensing image on the large scale remote sensing image. And this is how we do the airborne SAR processes. This is considered as the very convenient technology on the acquisition of the data, meaning that we can do the acquisition during the day as well as in the night, because this can through the fog and can through the bad condition of the weather as well as the cloud, etc., and so on, and we can coverage the area, large area, rather than the other technology. So nowadays we are pushing to develop this technology, especially for our industry and also like us in the PIG. So then later on, we do the technology on the extraction and the analysis using, for example, what we call automated feature extraction, or later on, we can also use the what we call artificial intelligence to help us on the digitizing and to help us on the identifying the object when we got the data from the space. And later on, we put the name on those every polygons, what we call as the toponymy processes. Nowadays, we also doing the facilitating this process by developing the ICETIR publication as well as the web technology, as we call as ICETIR. Then we can put our processes of the toponymy more easily. So this is a part of the feature of the ICETIR technology, which is the application that allow us to contribute to the name of the geographical name in the toponymic aspect on our large-scale image. So basically, those are the important on the large-scale mapping processes. And then also another important aspect is the participatory mapping, where the community can also involve and contribute develop our map. For example, on the developing the border map in the village level, in the region level, on the city level, as well as the national level, etc. and so on. So this is the example of the base map services of us. If we compare this with Google Map, might be in the Google Map they have more information but less precision. But in our case, we have more precision, though we could not yet cover all entire the Indonesia, but currently during these 2 years, we should or we do our best to cover this base map for entire the Indonesia in the large scale map 5,000. This is not easy for us because we as the very large country, if you have a look Indonesia, we spread from the west to the east more than 5,000 kilometers. So this is really very huge country. So to do the mapping, such as in huge country, we need more advanced technology, and therefore we are really do our best and struggle to come up with the solution of how we can cover the entire Indonesia on a very fast manner. I mean, within this 2 years, because we know that these base map are very useful to help not only to provide the data for the planning of the city, but also to provide the data to encourage to support the growth of the economic and digital economic, etc. and so on. So you can imagine if we put the west of Indonesia, Aceh, for example, in London, then you will get the Papua already in Iraq or in the Middle East. So really huge. If we flying from Papua to Aceh, you need more than 8 hours might be. So therefore, this our our effort right now to come up with this large map as soon as possible. Secondly, how this business opportunity on the using of the geospatial information. I show you this is some of the business and economic development opportunity using the large-scale mapping. For example, nowadays there is surveyor in the industry. There are the surveyor, the acquisition data. For example, if you're developing the infrastructure, developing the road, dam, building, etc., and so on, you need the precision coordinate. And our large-scale map can help this to support the analysis of the precision coordinate. And also nowadays you use the application based of the navigation. Many of the applications are right now based of this, and therefore this is also the opportunity of the development of the geospatial information technology itself, and also on the analysis of the regional development. We need also the map, we need the geospatial information data, and also for other application for our lifestyle, for example, on the game, on the entertainment, etc., and so on. Also, we need the application of the maps itself. So therefore, the technology on the map, we should come up with this much better in the future. This is one of the example how the base map technology are important for our daily life, which is the monthly active user of major rating hailing application in Indonesia, for example, Gojek and Grab. So you can see the progress since 2018, 19, and right now, which is the more than 20 million using the application. That is a very huge opportunity actually. Another place, for example, also the number of the people purchasing consumer goods via internet, and some of the information on this application and rely on the geospatial technology and mapping. For example, more than 100 million people, and purchase the product online also about 87%. Route of the automation system for logistic transport, for sure you need the map, and therefore this information are very useful to develop the business, to catalyze the business, and so on. In other sector, for example, we need also the geospatial technology on the electricity provider, for example, on the PLN, when they have look at the distribution analysis of the network, for example, on the development of the network and the development of the services to the electricity to the society, and they need the mapping on the detailed mapping, where they should put the tower, where they should put the network, etc., and so on. So really depend on the map itself. And also currently in the on the services and the economic services and the monetary services as well, we need the geospatial information, for example, the analysis where we should put the branch office, etc., and so on. So in a governmental sector, for example, on the provincial level or in the regional level, in the city level, we need the map in order to develop our RTRW, Rencana Tata Ruang Wilayah, or our spatial planning in the kota level, in the city level, as well as in the kecamatan level, in the sub-district level. We need this more detailed information. And good map rely on the, as I mentioned before, the geospatial technology itself. Later on, also the 3D smart city design and planning. For example, when we are developing the IKN Ibu Kota Nusantara, we need also the detailed geospatial information. If you have a look in the IKN, for example, the titik nol, the blue pillar one, is actually developed by us. The BIG developed this pillar. We're doing the measurement in that area, recording the coordinate, and putting the pillar in that path and as 0 kilometer of the Nusantara. So this is actually our starting point to develop the geospatial data in the entire of the IKN Nusantara for city design and planning. Also, in the economic point of view, some of the application, no doubt, they use the geospatial information in order to the transfer the logistic itself or to place the coordinate, etc., and so on. So again, also crowdsourcing data of the geospatial data. This is also the important thing. As I mentioned before, this is part of the participatory mapping, and therefore the participatory mapping is not only to develop our base map, but also to develop the other geospatial information platform, like in the social media, etc., and so on. So last but not least, also in the entertainment aspect, they use also geospatial information. They use the coordinate. For example, if we still remember a few years ago, we are very hot issues are using the Pokemon. Every places you dealing with this coordinate, you play here and there to catching up with the Pokemon game, etc., and so on. So, ladies and gentlemen, this is just to give you an overview and introduction of the how important is spatial technology in us, and I will be very happy to have discussion with you later on. I should close our presentation in this point. Thank you very much for your attention, and good morning to you all. I'll give back to Bapak Moderator. Thank you, Pak.
Thank you very much, Professor. A very interesting topic about geospatial technology that can be used to catalyze a vibrant economic. Me, myself, have several questions, but I will hold my question, and also for the participant that have a question should be hold for a moment. So we going to the second keynote speaker, which is Dr. Adrin Tohari from National Research and Innovation Agency, or BRIN. So let me read his curriculum vitae shortly. Dr. Adrin Tohari received his doctoral degree in Okayama University, Japan, also for his master degree, and received his undergraduate degree in Imperial College, UK. And he has very rich experiences regarding the geotechnical engineering. So we welcome the second keynote speaker, Dr. Adrin Tohari. Time is yours.
Good morning.
Good morning.
Thank you very much, Mr. Moderator. Good morning, everyone. My name is Adrin Tohari. I am from National Research and Innovation Agency. I would like to thank to the organizing committee to invite me as a keynote speaker for this very nice event, the International Conference on Engineering, Technology, and Innovation Research in 2022. Let me share the presentation material that I am going to share with you. Okay, I hope you have now seen my presentation.
Yes.
Okay. So, in this opportunity, I would like to share with you the research and the development about how we can stabilize the landslide in area where the groundwater quality is not so good to support the effectiveness of the groundwater drawdown method. My presentation title is the experimental study of the gravity-driven groundwater extraction method for slope stabilization. Perhaps you now have a question what I mean with the gravity-driven groundwater extraction method. So this is the outline of my presentation. I will introduce you with the background of this research, and then I will talk about the siphon drain principle for slope stabilization and the result of some laboratory experiment and the field experiment, and I will end this presentation with some conclusion from the result of this research. So, as the background of this research of this study, we already know that landslide is very common occurrence in Indonesia, but the one with we call the deep-seated landslide is have a huge impact to the infrastructure and also the residential area. And it's very common for the geotechnical engineers to face this deep-seated landslide with a common stabilization method, which is the bore pile. However, this stabilization method is not always work very well because the groundwater itself is still rising during the rainfall, so the stability is still affecting by the groundwater. As we understand that the influence of the rainfall infiltration will increase the groundwater level, and hence the water pressure within the slope, and the increase of the water pressure will decrease the shear strength and then the stability of the hill slope. So we can see that if we can control the groundwater level, yeah, during the rainfall event, then we can maintain the stability of the hill slope. Yeah, many studies have already indicate that when we draw down the groundwater level, then we can stabilize the landslide. And some method that already used to stabilize the landslide using this groundwater drawdown, such as the sub-horizontal drain, real well, and the new method is siphon drain. This is what we call the gravity-driven groundwater extraction for slope stabilization, the siphon drain. In all of these three methods, yeah, the sub-horizontal drain is effective, but it has some limitation that it cannot reach the deeper aquifer. The relief well is also effective, but has some limitation. The cost construction is very expensive. And the siphon drain, I will show you how the effectiveness of this method in the next slide. The principle of the siphon drain is actually very easy to understand. You may already you already doing this kind of technique to extract the gasoline from your bicycle, from your motorcycle tank to let's say to a bucket. You put the tube into the tank, and then you try to suck the tube, and then suddenly the gasoline will flow into the bucket. This is the principle, very easy principle of the siphon drain. As long as we have a different pressure within the system, then the liquid will start to flow from the high pressure to low pressure. And this principle is now applied to work for slope stabilization. What we do with the siphon drain is how we can draw down the groundwater level continuously, yeah, during the rainfall infiltration, during the rainfall event. We need to construct a vertical well, and then we insert a siphoning tube, very specially made, yeah, because it should withstand with the weather. And then at the end of the siphon tube, we have to install what we call a flushing unit. The flushing unit is a system that will maintain the vacuum condition in the system. So when there is a small increase of water table during the rainfall, then the system, the siphoning tube will suck the groundwater level from the vertical well, and then flow into the flushing unit, and will be discharged to surface drain system. The system is already applied in Europe, but we know that in Indonesia, when we consider the geological condition, there are some hill slope that may have a bad quality of groundwater, especially in the volcanic area where the sedimentation is easy developed due to the influence of the weather. Yeah. So in order to evaluate the effectiveness of this siphon drain system, when we need to apply to this geological condition, so we have to understand what is the factor controlling the effectiveness of this siphon drain, and when we apply to the field condition, what is the factor influencing this performance in the field condition. So a few years ago, we conducted an experiment in the laboratory to clarify the factor controlling the effectiveness of siphon drain method to lower a water table in a model slope. The objective is to study the effect of the drainage well location, the initial water level, and different rate of water table rise on the performance of siphon drains. Of course, these three factors is very important to decide where we have to install and in what distance the vertical wells should be constructed. So this is the experimental tank and the profile of the slope model. We constructed in the very small landslide tank with dimension 1 meter to 0.8 meter by 2.4 meter. And the picture below is the plan view of the constructed slope in the tank. In this laboratory experiment, this is the experimental apparatuses. Yeah, it consists of a constant head tank, and then the siphon well, and also some flushing unit. For each siphon well, the siphon tube is connected to flushing unit, and we also install a standpipe plastic tube manometer to monitor the change of the ground water level within the slope model. The constant head tank is used to maintain the height of the water level in the model slope. And also at the back of the slope model, we have what we call a gravel fill tank, is to prevent scoring in the model slope during the water infiltration. And what we call the flushing unit, you can see in the right picture, is consists of plastic pipe, double plastic pipe, and then there is some U-shaped stainless pipe to maintain the vacuum in the system. And this is the experimental program. Considering the objective of the study, first, for number one, the objective is to study the effect of the different well location. The location of the well is row number 1, 2, and 3. The experimental condition, we set the water level initially at 0.6 meters, and we use 5 siphon well. For the experiment number 2, the objective is to study the effect of different initial water level. And we decide the location of the well is row number 2. And the initial water level is 0.3 and 0.6. And we use a 5 siphon well. For the last experimental condition program, with the objective of the effect of the rate of the water level rise, the location of the well is row number 2, and the rate of the water level rise is 0.02 centimeter per second and 0.002 centimeter per second to 0.8 meter height of water level. If we go back to the schematic of the experimental setting, this is the siphon well in row number 1, row number 2, and row number 3. Yeah, row number 1 is in the middle of the slope. Row number 2 is on the flat area in front of the gravel tank. So the observation and the measurement is focused on the height of water table within the slope model slope using a standpipe manometers, and also we measure the discharge water from each flushing unit. And these are the results for the first experimental program to study the effect of the siphon well location. From this experiment, we can have some finding that the siphon drain, of course, lower the water table and consequently reduce the seepage phase area at the slope 2 of the well location. Yeah, if we see from this picture on the left top left, the initial groundwater level is indicated by red line, and when we consider the siphon well in row 1, row 2, and row 3, we can see that when the siphon well is located in row 3, then the groundwater level is decreased very significantly, more significant compared with row 2 and row 1. And so applying the siphon drain method required the good knowledge of the groundwater table within the slope. The discharge rate in the experiment row 2 and row 3 is slightly higher compared with row 1 in similar trend to the water level. So the well location will affect the effectiveness of the siphon drain method. For the experimental program to study the effect of different initial water level, at a low initial water level, the siphon drain lowered the water table, and the seepage phase at the slope 2 decreased significantly. At high initial water level, the siphon drain lowered the water table depths, but the seepage phase are still developed at the toe. So the installation of the siphon drain at lower water table condition will maintain the groundwater at low level significantly. The discharge rate at high initial water table condition 1.5 times higher than at of a low water table condition. So referring to the result of this experiment, the discharge rates are controlled by the initial water level. For the last experimental program, focused to study the effect of the rate of water level. During the experiment with the rate of water table rise 0.02 centimeter per second, the water table drawdown occurred to up to 15 centimeters, and the siphon drain result in the decrease of water table up to 10 centimeters. However, the seepage area still unchanged. During the siphon drain experiment with the rate of water table rise of 0.002 centimeter per second, the water table decreased up to 6.6 centimeters at the siphon well location. The seepage area was slightly lower than that in the experiment with the rate of 0.02 centimeter. So the siphon drain will have more significant effect on the water table in a low water table in a slope with low permeability. The conclusion of this laboratory experiment is the experimental results show that the siphon drain method effectiveness depend on the initial water table, well location, and the rate of water level rise. Second, the siphon drain method can significantly affect the when installed in a slope with high water pressure head. A significant drawdown of water table occurs at initially high water table, and a significant drawdown of water table occurs at a slow rate of increase in the groundwater table, in other words, in a soil slope with low permeability. Next, I will show you the field experiment of siphon drain for slope stabilization. The purpose and the objective of this field experiment is to evaluate the effectiveness of the siphon drain system with vertical well to maintain the stability of landslide masses in a volcanic hill slope in West Java. The objective was to evaluate the long-term performance of the siphon drain method for lowering the groundwater in the landslide area, and quantitatively evaluate the influence of siphon drain system on landslide stability, and to give some insight of factor affecting the effectiveness of siphon drain method in stabilizing the landslide mass in volcanic soil. This is the research location, is in the Cibitung landslide, Pangalengan. The big landslide occurred on May 2005, and it have an impact to the geothermal pipeline and some residence area at the top of the slope. So this is the picture, the aerial picture of the landslide. Yes, very huge. And this is the experimental layout. The topographic map on the left show the location of the vertical well, and also the tubing direction of the siphoning tube and the flushing unit. This is the construction of the vertical well. Yeah, we drill the well up to 12 meter, and then we insert the siphoning tube up to 10 meters depth from the ground level, and then at the end the end of the siphoning tube is connected to the flushing unit. And this is the schematic cross-section of the slope, the landslide area, and showing the location of the siphon well. And the picture on the right is the flushing unit installed at the toe of the slope. In total, there are 10 actually flushing unit installed there. And this is the initial groundwater level before the siphon drain activated. Yeah, in general, the groundwater level in well number 1 to well number 7 is very low, close to the ground level, and the groundwater in well number 9 to number 13 is very deep, yeah, from the groundwater level. And when we activate the siphon drain, we can see the effect of it. Yeah, the groundwater level in most of the vertical well, from vertical well number 1 to vertical well number 7, lower. Yeah, the groundwater level decreased very significantly. Yeah. However, there are some event where the groundwater level in the siphon well increase. This is because the siphoning tube experience clogging due to the sedimentation from the chemical reaction of the groundwater with the air. Then this is the discharge of the siphon well. Siphon drain well, yeah, the red triangle indicate the clogging of some siphon tube. We can see the discharge rate eventually constant to 2 meter cube per day. Is very significant discharge we can get from the system. And if we total the discharge rate in meter cubic per day, then we can see the average discharge, total discharge extract from the system is about 20 cubic meter per day in total. It gets constant at the end of the experiment. We conducted this experiment for almost 1 year. And in the event of high rainfall, the discharge rate is constant. So it indicates the siphon drain works effectively to maintain the groundwater and also the discharge rate. And this is the effect of the siphon drain to the surrounding well. Yeah, if you look at the effect of a siphon drain in vertical well number 10 to other wells, we can see that even the distance between the well is very far, about 4 meters, the influence of the drawdown in one well will affect also the depth of the groundwater in the neighboring wells. And to evaluate the effectiveness of this siphon drain, we conducted the numerical stability analysis. The left figure indicate the safety factor before the siphon drain is activated. The safety factor is almost indicate the slope is in the critical condition. Fs is 1.1, and the right figure, when the siphon drain activated, then the safety factor increased to 1.44. So this numerical analysis show that the landslide mass becomes stable even heavy rainfall occurred in the area. So as the conclusion from the field experiment, in most of the landslide area with a high groundwater level, the siphon drainage system can significantly reduce the groundwater level up to the depth of -7 meters with a significant total discharge rate up to 24 cubic meter per day. However, the siphon drain performance was affected by groundwater quality. So regular maintenance of the siphon tubing is necessary to maintain the long-term performance of the siphon drainage system on landslide area with low groundwater quality. Based on the series of numerical modeling, the implemented siphon drainage system effectively increased the stability of the landslide area. The safety factor increased from 1.1 to 1.4. And monitoring the effect of the siphon drain system on the groundwater table in the observation well suggests that the siphon drainage performance is affected by geological complexity of the study area. Among other factors, the fracture zone, which control permeability and the groundwater flow, is the main factor affecting the groundwater depth variation in the siphon well. So the subsurface hydrological complexity should be considered in designing the siphon drainage system to stabilize the landslide. Well, I come to the end of my presentation. Thank you very much for your attention.
Okay, thank you very much, Dr. Adrian, for very interesting presentation about the effectiveness of a gravity-driven groundwater extraction method to increase slope stability. We will hold all the questions and we're going to go to the third keynote speaker, which is Professor Heru Purnomo. I would like to read his curriculum vitae shortly. Professor Heru Purnomo was born on June 28 and he received his doctoral degree on 1993 in University d'Orléans, France. He has published so many papers, in total 60 papers in several international journals and conferences proceeding. So Professor Heru Purnomo would like to deliver his topic about concrete material. So Professor Heru Purnomo, time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. Thank you, Mr. Moderator, to introduce my CV, and thank you for the committee that I have been invited to the ICETIR 2022. So my talk will be about hot roll and cold form steels, and it will be focused on the properties and the behavior of those two kinds of steel. So the presentation outline, first, I would like to introduce the current problems of the cold form steels, and the second topic will be about the comparison between hot roll and cold form steels, and third is about the material properties, and next is about the manufacturing process, and then I will show you about the design standard that is used in Indonesia. And 6 is about the failure mode or the instability of those two kind of steels. And then I will come to the connection type. And for the number 8, it's about the residual stress from both steels. And short talk about fire protection and corrosion protection at the end. So there is several collapse of cold form rough truss in Indonesia. So, but we don't have any investigation that is done for this collapse. So, as this is the current issue, I have asked some local contractors what is their perception about cold form steel. I don't ask many. It's just about 3 local contractors, and they have perceived that cold form steels behave like hot roll steels. And second, hot roll steel formula is used for cold form design calculation. So they think that hot roll steel formula can be used for designing the cold form roof truss. And the third perception is bolt connection formula is used for calculating the screw. And when I asked about the screw location, they said that there is no problem if they put the screw which is not which is too near the edge of the profile. And hello, is my voice is quite clear?
Yes, Professor.
Okay, thank you. So I continue. And those 4 issues is the perception of those local contractors, and are these perception contribute to the collapse of the cold form steel trusses? So, but it is difficult to answer because there is no studies that has been done until now, and there is also no investigation that has been done by the local government, for example. So, but my talk will explain about the similarity and the dissimilarity of the properties and the behavior of those 2 kind of steels. So in terms of cold form steel, in Indonesia we call it by baja ringan. And for the standard, it is called by canai dingin. On the other side, for hot rolled steel, is called by baja. And then for the application for hot rolled steels, we can use this kind of steel for buildings, bridges, towers. And cold form steel can be used for roof truss, carport roof, corrugated sheet. And we will have the explanation of connection detail on the next section. The thickness is very different between hot rolled steel and cold formed steel. Cold formed steel is quite thin. Its thickness is ranging from 0.42 millimeter to 8 millimeters. But it's not many industries that manufacture cold formed steel with those 8 millimeter thickness, except several home industry. And for the codes, we have for the two kinds of steels, we have already the codes. And if we see the related association in United States, then the hot rolled steel is under American Institute of Steel Construction, or AEST. But for cold formed steel, it is a different association. It is called by AC, American Iron and Steel Institute. So if we see the section shapes, we have several shapes for hot rolled steels. For example, that is often sell in Indonesian steel industry is wide flange, L angles, I beam, channel, and there is also hollow section. On the other side, we have many shapes for cold formed steel, from canal. We can have also, we can build section from two canal, for example, that made an E section. And the application of hot rolled steel in the world is coming from already 300 years. Yeah, after the iron decay. So I would not know. I will not explain about this structure. So you have seen many of them already in Indonesia and on the other part of the world. And the application of cold form in Indonesia is focused mainly on the roof truss. Yeah, and some engineer has tried to establish, for example, a short span truss bridge. And in Japan, for example, they already use many kind of cold form steel application. For example, for the house framing. About the advantages of using hot rolled steel, so the manufacturer is without delay, so does not so it is easy to shape and made in larger size. And this kind of steel has high strength and stiffness, and also have the ductility, and it is in terms of quality, it is we have a good quality or uniform quality. On the other hand, for cold form steel, it is lightweight. This is easy to construct, and we have to choose. We can choose appropriate shape that we want to use, and the design methodology is available for any cross section. Okay, and there are these advantages of both kind of steels. So the similarity of these advantages is first is about the residual stress. The two kind of steels has residual stress after manufacturing. And the two kind of steels is low in resistance to fire and also corrosion. So this is the same disadvantages between the two kind of steel. So if we see the growth demand of the steels, so for the last, for example, the last from 2010 to 2013, we have increasing growth for the hot roll coil, plate for the cold roll coil, and for others type of product. So it is increasing. And for the 2020 projection, we have projection is about 1.5 compared to 2013. So we come to the topic of manufacturing process. So the hot rolling process should be done with pressure, and it is also done for hot rolling. So the main differences between hot and cold rolling: hot roll steels allows partial buckling of the section, so that the bearing capacity of the bar after buckling can be fully utilized. And hot roll steel does not allow local buckling of the section. The causes of residual stresses in hot roll and cold roll steels are different. So the distribution on the cross section is also different. The residual stress distribution on the section of the cold form, which is thin, is a type of curve, but for the hot roll is a film type. So this is again, you can see how the process of manufacturing of hot roll steels. So the hot roll steels member are manufactured by roll press at very high temperatures. It's over 1,700 Fahrenheit. And for the manufacturing process of cold form steels, we have three kinds of process. The first is what we call by brake pressing. And the second process is by roll forming. And the third process is by folding the plate of cold form steel. So we can see here that the brake pressing is done for simple geometry and for the short length of the length of the profile. And for roll forming is done for complex section and long members. So commonly use this member for rough truss, floor, house framing, and corrugated sheets. So the machine that are used for this roll forming are controlled with punching, cutting, dimpling, and printing capabilities at general speeds of 20 to 40 meter per minute. So this is how the roll forming has formed the profile of the cold form. So for each steps, there are some deformation that has been done by the cylinder. You can see here from the first step to the second to the third until the sixth steps that form the final shapes of the cold form steel. This is the real picture of the roll forming machine. And the third process is about to fold the plate of the cold form steels. So each steps has an effect to form the part, one part of the profile. So to, for example, if we want to have a canal profile, it is done at minimum 4 steps, as you can see at the slide. So now we come to the material properties. If we see the stress and strain relation of steels, depending on the quality or the strength of the steels, we can have normal steels for BG 34 until 37. We can have the plastics range. It is clear about the plastic range, and after that we have a strain hardening. But for higher strength of steel, for example, for VG 41 until 55, we don't have a clear location of the yield stress, and we can do it by taking the offsets of the strain to define the yield stress. And this is how the cold form behaves. So if we, for example, we put a tensile load, or we do a tensile test, in normal condition, we have a stress strain curve like the moderate strength hot roll steels. So there is a linear portion, and then we have a plastic plastic plateau, and then we have strain hardening. And to have an increase in ultimate strength, we have to to do several steps. So if normally there is unloading in strain handling range, it can be seen on the line B. And if we immediate reloading this force, we come to the curve that is like the virgin ductility. So we have a curve A, B, C, like the previous original tension test for the cold form steel. But if we reloading after what is called by strain aging, so we will have an increase in ultimate strength. It can be seen that after unloading, we wait for several times, and depending on the temperatures, we have not to do it immediately. Then we will have strain aging, and the curve will be take the D line. So we have an increase in ultimate strength, but this technique create a residual stress. So if we ignore or we erase the residual stress part, we come to this stress-strain relationships. So here is the hot roll steel and cold form steel ultimate stress and yield stress, which is depending on the grade of its kind of steels. So if you see that for cold form steel, for G550, the yield stress and the ultimate stress are the same, are in the same level. On the contrary, with the hot roll steel, we have a good elongation. Yeah, but for the G550, for example, for the cold form steels, we have an elongation of 2%. So it is small. So it can be seen to this strain curve for cold form steel G550 that we have tested at GTEC laboratory. So you can see the the profile of the stress and strain, where the ductility is not so big. So if you see this, you can go back to this stress strain characteristic, which is represented by the line B and D. So we can see here the line B and D. Yeah. So if you see the after the profile condition after the tensile test, we don't have any effect on Poisson. It is a brittle fracture, as you can see, and at the right bottom side. For two kind of thickness, we have tested for 0.65 and 0.75 millimeters. So about the design standard, we have for the hot roll steel, we can refer to SNI 1729 2015, and for the cold form steel, we can refer to SNI 7971 2013. And we can refer also to the IESA steel construction manual for the hot rolled steel, and the Indonesian SNI for conform steel is based on the Australian and New Zealand standard. And this is the other resources that you can read for the hot rolled steel and for the cold form steel. And the next session is about the failure mode or the instability of the two kinds of steel. For hot rolled steel, for example, we can have local buckling, flexural buckling, or lateral torsional buckling at a beam when it is subject to load. And for the cold form steel, we can have also the local buckling, but it is very sensitive as the cold form steel is very thin. We can have web crimping and distortional buckling. We can have also shear failure, this kind of profile. So if we see the hot roll steel, we see the compression test of steel member, we can have just compression load, for example. Yeah, so the member is subject to single compression load. We can have depending on the shapes of the profile, we can have flexural buckling or torsional buckling, or we can have flexural flexural torsional buckling. So this is for the hot roll steel. But for cold form steel, we have many kind of stability when a member is subjected to compression force. So this is how the flexural torsional happen to the member, and we can have web local flexural, distortional flexural. So this is combination between two modes of failure, or we can have local distortional flexural. We can have at the web. Yeah. So here I repeat for the failure modes for the lip in compression. So at the left, your left side of the in the slide, we have a single modes of failure. So you can have local, you can have distortional, you can have flexural, you can have torsional, you can have flexural torsional. Yeah, but we can have also combination of mode. Yeah, for example, we can have local with distortional. We can have flexural combined with locals, and we can have other several combination of interaction of two modes. Yeah, interaction two failure modes. So you can see here that the behavior of the failure will be modified by the presence of two couple modes. So if we focus on the imperfection in thin wall cold form steel members, we can have three kinds of imperfection. The first imperfection is mechanical imperfection. So because of the shape of the cold form member is not symmetric. For example, for the canal profiles, we can have what we call by loading eccentricity, and there is also eccentricity at the support, and imperfection at the material side is by forming process. We can have higher ultimate stress, but on the other side, we will have also the residual stress. And there is imperfection at the geometrical situation for the member. We can have a local imperfection, or we can have a global member imperfection. So this is just an explanation about the local buckling that can happen to the member, canal for member. So the local buckling may occur before yielding, but we can take into account the post-buckling reserve. So it is allowed in the design to achieve economic section. So this is on how the effect of local buckling on cold form steel column. So if we see the ideal curve of Euler, which is representing by the non-continue line, if there is any imperfection, we call it by erosion due to imperfection, and then we can have also local buckling effect. Then the final curve will be as seen here with something if we calculate by a reduced section. So it gives us a lower curve. So this is on how the distortional buckling happen. Yeah. And here again, it is you can see on how the web crippling is happened. And we can have also the flexural torsional buckling. So this is a combination between flexural buckling added by torsional buckling. So because as you see here, that the centroid and the shear center is not on the same location, and if the force or the load have some distance to this shear center, then we will have a torsion moment. So we will have flexural condition in addition to the torsion moment. So this is about the twist, torsional buckling. As the load does not pass the shear center, and this member will twist. And then we come to the connection for hot rolled steel and cold formed steels. So for the hot rolled steels, in Indonesia, we have already the bolt, the common bolt, or the high strength bolts. The welds is already done for many years in Indonesia. But for the cold formed steel in Indonesia, it is done with screw. So it is rare to use bolt, repair, press joint, or reset joint or adhesive for uh, joining members. Yeah. So in cold formed steel section, we have modes, failure modes that are different with the hot roll steels. The bearing mode are also exist in the hot roll steel, but not the tearing and the tilting. So this is the differences of failure mode of the connection. So why the screw connection is used for the cold formed steel? Because it is very easy to use and it's very practical. So it's no heavy equipment is needed for the installation. And then this screw connection has a limit that more than 3.2 millimeters, it cannot be applied. Okay, so I will skip this part. Now, if we see on how the bolt connection design, we have to see the strength of shear and the strength of bearing. But for the screw nut connection, we have to see also the tilting, the tilting beside the bearing capacity of the screw connection. We have to see also the tilting strength, the tilting strength. So you can refer to Hankook studies at 2007, and he provide several formula for calculating the screw. So we cannot use bolt connection formula for screw connection. It is very different. So here is the application of the bolt for the hot roll steels, and we can also use bolt for cold form section. But as you see, the washer should be thick now to be the bolt connection on the cold form steel can be used. So this is I take this picture from Prof. Irianto de Bobroto dissertation. So the failure modes of the bolt connection in shear, we have several modes: tearing, bearing, and tensile variant along the width of the profile, and there is also failure of bolt. And there is also refat, or in bahasa Indonesia we call it by paku keling. So, but in Indonesia we don't use this kind of POP refat, And there is also self-piercing refat connection. It's rare to be used in Indonesia. In Indonesia, people use screw, this kind of screw. So the screw can have two kind of can be in to failure mode. So you can see that there is on your right top, you can have tilting failure and bearing.
I'm sorry, Prof. It
Yeah?
is 2 minutes left from your presentation.
How many
please.
minutes?
2 minutes left.
Thank you.
Yeah.
So I will go. This is the screw connection for the cold form steels. Yeah. And here is the residual pattern of the hot roll steel and the cold form steel. Yeah. So this is how we can measure the residual stress. There are many methods, yeah, to define to find the residual stress. So this is how the residual stress exists in the hot roll steel and the cold form steels. So we have also with my students, doctoral students, we have measured the residual stress using X-ray diffraction method at Serpong. So this is the result of the residual stress on the cold form steel. So it's just look like this the same result found by other researchers, but what we have is we measure with the thickness of 0.65 and 0.75. So it's about fire protection. For the cold form steel, we can use plasterboard, and for the protection, we can use for the cold form steel, can coating zinc or aluminum zinc or with aluminum magnesium zinc. So thank you for your kind attention.
Thank you very much,
Thank
Professor
you,
Heri
Mr.
Purnomo.
Moderator.
Very interesting topic about the performance of two types of different steel, which were hot roll and cold form. Now we come to discussion session. So for the participant who have the question, you may submit the question to the chat box and we will read your question. And is there any questions? Okay. I will wait the question on the screen and read the question. Yeah, we have a question, first question for Professor Aris Marfai. The question comes from Pak Wahyu Widianto. So Pak Wahyu Widianto is a loyal customer of Temnas for photography, topography, and Patnas for bathymetry, which can be downloaded for free on the BIG website. Now the resolution of Temnas is around 8 meters and Patnas is 180 meters. Will the resolution of both maps be increased in the future? For example, become 1 meters and 20 meters, because it will help for many simulation. Prof. Aris, please respond for this question.
Yeah, first of all, thank you very much for the question. If I'm not mistaken, the question was related to the Timnas topography and Patnas. Before I answering this question, actually, as part of our services is to provide the geospatial information data, including the bathymetric national and digital elevation model national. Currently, our Temnas is built from our basic atau peta rupa bumi, the basic map, and for sure once we finish 5,000 scale of the basic map, then our TEMNAS will be increased. So I repeat again, mainly our TEMNAS is developed from LiDAR and also some of the basic map in a scale of 50,000 and 25,000, which is it's useful, but we need more detail of these TEMNAS. Therefore, these 2 years we will develop the basic map of 5,000, then we can use this for TEMNAS. Also, for the bathymetric national, actually there is stakeholders who are involved on the bathymetric data, not only in the PIG, but also previously in the LAPAN, currently in the BRIN, but also in the PUSIDROSAL. So we share the data and we share our capacity to mapping the bathymetric to cover all the entire Indonesia. And for partners currently still 180 meter, but for sure, when we finish with 5,000, we will go for the next step, which is of the marine mapping, including the bathymetric. So in the near future, we do believe that we're quite confident to finish this one.
So thank you very much for the response, Professor. Is there any other question? We still wait the question to be displayed on the screen. Yeah, this one comes from Ms. Hendriawan Ahmad to Professor Aris. How important the use of Internet of Things, IoT technology, to support GIS application? Is GIS application used in BIG only use satellite imaging or remote sensing?
I would like to give you the simple description like this. When we build our basic map, our digital map, we are fully depending on our reference station. And for the reference station, we have 3 different reference stations. The first, we use pasang surut station, or what you call it, sea level rise station, a tidal station. We have around 250 tidal stations across the Indonesian islands, and this serve us to a reference system to give the better reference on our system mapping. The second station is the course, continuously operating reference station. And for the course, we have around 200 stations, and other institutions like ICETIR BPN, they has more than 250 stations. And the third, we use the gravity measurement, both on the terrestrial gravity and airborne gravity. We just covered all the entire Kalimantan gravity this year and the last year. And we provide this for our reference station. For those 3 things, we need the Internet of Things. We need the support of the Internet, because we acquire the data every minute, every seconds. So we send from the station to our base is every 5 seconds, but the data contain every seconds. So in the real-time data, we need the Internet. This is the first case. The second case, when we providing analysis of the geospatial information through web services, certainly we need this Internet. So, but actually this is the basic Internet of Things as an example. In advance, we need and we use the Internet for many services, including the automatic what do you call it, automatic identification object from the remote sensing data, automatic analysis, object analysis from this, our remote sensing and other geospatial information data. And last but not least, whether we need whether in our GIS application we are depending only of remote sensing data. Actually not, because we use also airborne or also terrestrial measurement. If we are talking about the precision of the geospatial measurement, so for example, just currently we are doing right now on the measuring or mapping of the country borders between Indonesia and Malaysia. We do this based on the terrestrial measurement, so we could not do this based on the remote sensing because we need the very precision coordinate, and this is very sensitive one because you are talking about the border among the countries. So those are some examples.
Thank you very much for your response. So one more question, or can I, as a moderator, ask question to another keynote speaker? Or please just display the question on the screen. I will choose the question. Oh, it's still to Professor Aris Marfai. So I would like to ask to another keynote speaker. First, for Dr. Adrin Tohari, it was a question sent to my cell phone. In your opinion, who will be involved to conduct the regular maintenance that may be required to maintain the effectiveness of your method, Dr. Adrin?
Okay, thank you very much for a good question. Who's responsible for the maintenance?
The stakeholder, maybe government, and
Okay, it's the owner of the slope, the area where where the siphon drain is installed. For example, if the mining company install the siphon drain to maintain the stability of the cut slope in this his consist area, then the mining company itself responsible for the maintenance of the performance of the siphon drain. After they get training from the consultant who install who have a work to install the siphon drain.
Okay, thank you for your response. And the last question for Professor Heru Purnomo. This is also the question sent to my cell phone directly. What is the best way to prevent the so-called catastrophic accident for collapsing steel structure, Professor?
Thank you for the questions. So, yeah, first, the designer or the contractor should design appropriately according to the standard. So, and then it should be supervised by someone who really know about the cold form steel structure calculation. So in Indonesia, if we build, for example, roof truss for landed houses, for example, the seller of these cold form members, they sell a very thin section, and it gives very low prices, but it's not good for the roof truss. And if we see the brochure or the leaflet that is given by the manufacturers, it is they give the distance between roof trusses. Yeah, it is just for light roof, for example, steel sheet, but it is not allow for example, ceramic beton or genteng that is very heavy.
Yeah.
Then it should be, the distance should be shorter. The normal distance given by the manufacturers is normally 1 meter, 120 centimeters. And if you have a heavy roof, genteng, yeah, then you should shorter the distance of the roof truss. You should not follow the brochures, because the brochures is only low for light roof. So this and if there is supervision, it can be that he or she can see whether the connection is installed in good manner. I see several proof that only there are only two screw. Yeah, two screw.
It's
and
not enough. Just using
it's not
two screw.
enough.
Yes.
And as the contractor perceive that it is like bolts. Bolt have washer. So if the shear strength does not exist, then the bearing strength will take place. But in screw connection, as we don't have any washer, then we don't have any second defense. And often the man who do the installment of the screw, they often make a big hole. The big hole is not appropriate for screw, because it will create imperfection at the connection. So I think it is better that there is a dissemination of cold form to the
hot roller
contractors or for the seller.
Yeah. We have your point, Professor. Thank you very much. And to conclude, we have 3 different topics, and all of the keynote speakers have deepened our knowledge in the field of slope stabilization and geotechnical special and the behavior of steel material. So the time is up now. Thank you very much again for the keynote speaker. So I will give back the stage and times to the Master of Ceremony. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you for the moderator and honorable speaker.
So, ladies and gentlemen, this is the end of the plenary session. And the next session is parallel session that would be commenced after the lunch and prayer session. So please, all the participants, you may taking your break time and you may take your preparation. And we will meet again at the 1 p.m. 7 plus GMT. Thank you.